test review. So for the number one, you do vertical asymptotes. To do vertical asymptotes, you need to factor. You factor the numerator. In this case, the numerator is already factored. 1, no other factors of 1. So that's factored. The denominator, you look for the greatest common factor as 2. You take a 2 and divide it undistributed out of binomial. We're left with x squared minus 4. Inside parentheses, we can factor that further. So we'll continue to factor. I'll just write the numerator. 2. X squared minus 4 is the difference of squares. You can square root both terms, and there's a subtraction in the middle. You square root x squared, you get x. And you square root 4, you get 2. One of the binomials, you get positive, one's a negative. It just always works out that way. Now for vertical asymptotes, you look to see first if there's anything in the numerator and denominator that you can cancel out. And there's not. There's a 1 in the numerator, nothing else, nothing can simplify. So nothing simplifies, so then you look at which factors have x's. Yeah. You have x plus 2, that's going to be part of your vertical asymptote. You can use that. And x minus 2. Set them both equal to 0. X plus 2 equals 0. X minus 2 equals 0. Solve both of them. So minus 2, minus 2. And you get x equals negative 2 as the vertical asymptote. And for this right one, you'll add 2, and you get x equals positive 2. So both of those are your vertical asymptotes. Number 2, horizontal asymptotes. This is off the biggest exponent. Biggest exponent of the numerator is 2. Biggest exponent of the denominator is 2. We're looking at they're matching. When they match, you look at the coefficients in front. So the coefficient of the numerator is negative 1. Coefficient of the denominator's biggest exponent of the term is 1. So our horizontal asymptote is negative 1 over 1, which simplifies to y equals negative 1. Y equals is a horizontal line. In review, when the numerator's exponent is smaller than the denominators and when it's bigger, review those on the 9A, 9B notes. Right on the number 3, I already have factored for you. So you're going to see this on the test also. It's already factored. Certain cases. We're looking for the holes in this problem. Holes are where, when it's factored, what simplifies. So our x is simplify, and our x minus 4 is simplify. Whatever simplifies out, whatever you cancel out, that's going to become your hole. So x canceled out, so we set it equal to 0. We also set x minus 4 equal to 0. Now, x equals 0, that's already solved. But x minus 4, that's not solved. We need x equals. So we add 4. You get x equals 4. We have x equals 4, and x equals 0. Both of those are going to be your holes. There is a y coordinate that comes along with it. If you really want to know what the y coordinate, find the holes, you would just substitute in the simplified form. So we substitute in, find the y value of the hole, that is. You substitute in 0, the left side doesn't mean anything, it just means you're substituting in 0. And 0 plus 5 in the numerator, that's the only thing that's left in the numerator. And 0 minus 5. And negative 5 over negative 5, which is negative 1. So your x value is 0, and your y value is negative 1. So if you really want to find the actual coordinate of the hole, there you go. And this will also work for 4. I won't work out here. I don't require you to do it. Just the x value is good enough. Number 4, take all your greatest common factor of the numerator. So we have to find holes, vertical asymptotes, and holes. But I guess we should find horizontal asymptotes first. So your biggest exponent, the numerator is bigger than the denominator, so there are no horizontal asymptotes. Then we're looking at factoring. So take out your greatest common factor, the numerator. And while I'm doing it, I might as well do the greatest common factor of the denominator too. And then we gotta continue to factor this because I can see that I have a difference of squares in the numerator. So x plus 4, x minus 4. And in the denominator, I have another difference of squares. X minus 2, x plus 2. Now we're looking at, is there anything in the numerator and denominator that can cancel out? No, so that means there are no holes. Nothing cancels, no factors cancel that have x's in them, so no holes. Vertical asymptotes are going to be the two or the remaining factors of the denominator that have variables. So we have x minus 2 set equals 0, x plus 2 set equals 0, and solve for both. You get add 2, you get x equals 2. That's a vertical asymptote. And subtract 2, you get x equals negative 2. Another vertical asymptote. Alright, for 9c, we need to graph. So number one, we're going to have to sketch the graph. So first, I want to find, well, it's already in factored form. Let's put a parenthesis there. Anything in the numerator and denominator I can simplify. We have x plus 3, so that means the whole. In this case, there's only one whole because that's the only factor that simplifies. And so x plus 3 equals 0, and subtract 3, x equals negative 3. So you can substitute negative 3 into the graph, to the simplified form, and find the y value, but I'll also show you how I do it on the graph once we get there. So that's the holes, vertical asymptotes. That is found with simplify the denominator, what's left after you simplify, and x minus 1, so the vertical asymptote is at x equals 1. So at x equals 1, I'm going to put the vertical line. Dashed. Dashed means that it's not technically there. It's an imaginary line that your graph cannot cross. And now we got to look at horizontal asymptotes. Unfortunately, this graph already got simplified. There's no polynomial function. It's all in factored form. So we need to multiply it back out. Multiply it out. So this is distributing, double distribution. So just to cut time short, it's going to be x squared minus 9. In the denominator, it's going to be multiplying 2 times x plus 3 times x minus 1. You're going to get 2x squared plus 4x minus 6. So that's multiplying it all up. Look at your biggest, so now we're doing horizontal asymptotes. We're looking at the biggest exponent of the numerator, 2. Biggest exponent of the denominator, 2. So they're matching. So we're looking at the coefficients, 1 over 2. So y equals 1/2 is the horizontal asymptote. Now I'm going to draw in a horizontal asymptote at y equals, so I go on the y value of 1/2. That's a horizontal line. And when you draw these, it's not going to be perfect, but I expect it to be good. So somewhere close to 1/2. And now we got to draw this graph on the calculator. So I'm going to now pull up the calculator. So here's the calculator. I put the original equation, whatever it is, put that in the y equals. I hit alpha y equals to get the fraction the way it is. Alpha y was entered. And when I started off, I always go zoom 6 just to start, get a nice recount. And what you're going to do here is you're going to just look at the shape of the graph. And what I usually do is I go to the table and I pull out some points, some coordinates that are not fractions. So 3, 0, put that on 3, 0. And see if there's any other points. So negative 1, 1, negative 1, 1. And there's no other coordinates. You can see the errors. The errors are either vertical asymptotes or holes. So you can also kind of look from there, make sure you're right. Now I'm just going to draw the shape. So the top left starts right above the asymptote, goes right along it. And it goes right to the left of the next asymptote. Your graph should not cross the asymptotes. And on the bottom right, it stays right to the right of the asymptote, and it stays right underneath it. So the last thing you have to do is you have to put the hole into the graph. So the hole is at negative 3. The hole is at negative 3. So what I do is I go over to negative 3 on the graph, and I look vertically at negative 3. Where's my blue line, my graph, across negative 3? It's right here. So I just draw a little hole, a little 0 there. That's the hole. Alright, next problem looks looks like we have to do the horizontal asymptote and vertical asymptotes. So for this, horizontal asymptotes, let's look at the biggest exponent of the numerator, 3. Biggest exponent of the denominator, 2. So the exponent of the numerator is bigger than the denominator. There are no horizontal asymptotes. If it switches around and the numerator's exponent is smaller than the denominator, then it'd be y equals 0. Vertical asymptotes, you could factor it, but in this case, I'm just going to look at the graph. I see a vertical asymptote right here at -3. So x equals -3. And I also see another vertical asymptote here at +3. Asymptote is just where the graph splits, or there's a vertical line or a horizontal line that splits your graph into 2 different parts. So that's that. You could do it by factoring also. Number 3, we can find vertical asymptotes solely factored already. So vertical asymptotes, we have x cubed. So I'm going to simplify first. X cubed divided by x is x squared. X plus 1 and x plus 1 gets simplified out. So what's left after simplifying in the denominator is x minus 3. That's going to be a vertical asymptote. You set x minus 3 equals 0 and solve for it, just like you did in other problems. And with the x equals 3, your vertical asymptote. The holes are going to come from what did you simplify? So we simplified an x in the denominator, so x equals 0. We also simplified x plus 1. So when you set x plus 1 equal to 0 and solve for it, you get x equals -1. So I'm good with you just labeling the x coordinates of the holes. And on number 4, here, you're going to have to sketch the graph again. So first you're going to want to find the horizontal asymptote. So the numerator's exponent is smaller than the denominator, so the horizontal asymptote is y equals 0. Now we look to factor. The numerator is already factored. The denominator you can factor into the a term is 1. And there's no greatest common factor, so when we do what two numbers multiply to c, that add up to b. And that's x plus 2 and x plus 1. Now you can see that we simplify. X plus 1's cancel out, so we know that there is a hole. It is at x equals -1. There's a vertical asymptote at x equals -2. That comes from what's left in the denominator and just the opposite of it. Set it equals 0 and solve. Now let's draw this graph. First we have to do this in the calculator. So when I put it in the calculator, I always put in the original equation. That way any of my calculations, if they're wrong, won't affect the actual graph shape. And then I can kind of cross-check some things. So we go to graph this, just to get the kind of general shape of the graph. I go to the table, second graph, define some coordinates. So I see -3, -1. And that looks like it. -3, -1. That's it. So -3, -1. You also can see the errors. I have an error at -2 and -1. Those are the holes and vertical asymptotes. So that's kind of a quick cross-check. From the table, you can't tell what is a vertical asymptote or a hole. From the actual graph, you could tell a little bit more. You can see if you go over to -2 on the x-axis and do a vertical line, that would be an asymptote. You would split the graph into 2 different parts. So that's what we got, the vertical asymptote at -2. So, all right, we had -3, -1. Well, actually, let's draw the vertical asymptotes first. So vertical asymptote, draw that. -2.
That's something if you were taking the after school.
Alright, sorry about that. And the horizontal asymptote at y equals 0, so we go to 0. Y. Draw a dashed line again to represent an asymptote. You can label it if you want, y equals 0, x equals -2. In case your drawing's a little off, I can see that that's what you have to do. And then let's look back at -3, -1. And let's look at the graph again. So the graph starts at the bottom left and curves down. So it goes bottom left, curve down. Always do not go through asymptotes. And the next part is top, goes in, starts at the top and middle, and then goes to the right. Stay within the asymptotes. Do not go through the asymptotes. Our last step is to look at the holes. The hole is at -1, so I go to -1, this point here, and I look vertically. Where's the graph? My graph that I just drew intersect with 1 as the vertical line. And it looks like right here, so I'll just draw a big hole right there. And that's what I'll do with the hole. So that's x plus 1. Alright, on 9c, this is just factor and simplify. So we have factor in the numerator. There's no greatest common factor. A is 1, so you just do what two numbers multiply to c that add up to b. In this case, it's x, it's -7 and -8. And you look at the denominator, you have x minus 7. And look, see what numerator and denominator you can simplify. And what's left is x minus 8 over x plus 1. That's the simplified expression. Next, number 2 is the same thing. Factor. The numerator can be factored, greatest common factor, 3. I always look for greatest common factor right away, you should. And then denominators also I can factor out of 3 as the greatest common factor. That's the first step. Next step, you can see that we can factor actually further. The numerator, in parentheses, is a difference of squares. Square root x squared, you get x. Square root 1, you get 1. So that's going to be x plus 1, x minus 1. In the denominator, you have the a term inside of the parentheses is 1. So you do which numbers multiply to c that add up to b. And that's -3 and -1. Now we just, after everything's factored, we look at numerators and denominators. What can we simplify? 3 divided by 3 is 1. I'm just going to write the 1, but I just wanted to write it just to show you. X minus 1 divided by x minus 1, again, is 1. You really don't need it there. And what's left is x plus 1 in the numerator and x minus 3 in the denominator. Number 3 is the same thing. We need to factor. So the greatest common factor of the numerator is 8. Greatest common factor, there is 1 in the denominator, is 3. And keep going. Greatest common factor of the numerator, or not greatest common factor, the factor of the trinomial inside of the parentheses. We have a quadratic, that's a trinomial. And for that, you look at a is 1, so then you do which numbers multiply to c that add up to b. B is -1, and that's x minus 3, x plus 2. The denominator, again, it's the same scenario, it's a quadratic, and it's a trinomial, 3 terms. A term is 1, so you do what two numbers multiply to c that add up to b, and that's x minus 10, plus 10, and x minus 3. Now everything's factored. You look to see what can you simplify. Numerator, denominator, 8/3 does not simplify. X minus 3 will simplify out. And what's left is 8 and x plus 2 over 3 times x plus 10. Nothing else can get simplified. That's the final answer. Moving on. Last one. So select all equivalent expressions that apply. Really got to be careful here. There's probably going to be more than one answer. Every time I ever see this, there's more than one answer. So at every step, stop and look at the answers. So right now, if I look at the answers, there's nothing like with the beginning, so you don't have an answer. But first thing we're going to do, factor. So the numerator, there's no greatest common factor. A is 1, so it's like we just did. Which numbers multiply to c that add up to b, which is 1. And that's x plus 4, x minus 3. In the denominator, the greatest common factor is 3x. So we divide all 3 terms by 3x, we get x squared plus 8x plus 16. Okay, let's carry that down. So let's look to see, is that part of one of our answers? No, unfortunately, that is not one of our answers. So let's keep going. We have x plus 4, x minus 3, the denominator 3x, and a term inside the parentheses. What's a quadratic? Again, that is a trinomial. What two numbers multiply to c that add up to b, and that's 4. And before we simplify this, let's make sure that if there's any answer that is exactly like this, and it looks like A is. So we'll circle A. Now let's simplify. X plus 4, x plus 4. It does not matter which x plus 4 you simplify within the denominator. What's left is x minus 3 over x times x plus 4. And that is d. So technically I could have had more than 2 answers. I could have wrote this one up here, that second step, or the first step actually. I could add that as one of the answers also, but I didn't. Alright, the class ready for this test. It's happening next class. Thank you.